Ice cream in definition of chemistry is the dissolved solutes, mostly sugar, in the liquid portion of the mixture lower its freezing point. Normally, liquid nitrogen, which boils at -196 degrees Celsius, will be used in freezing the ice cream processed. Because of the ice cream freezes so quickly, so the size of the crystals is small, resulting in a creamy texture. To get a perfect taste and texture of ice cream, it must go through each of the specifics process. Mixing. The milk fat source, non-fat solids, stabilizers and emulsifiers are blended to ensure a complete mixing of liquid and dry ingredients. Pasteurizing. Ice cream mix is pasteurized at 155 degrees Fahrenheit, 68.3 degrees Celsius, for 30 minutes or 175 degrees Fahrenheit, 79.4 degrees Celsius, for 25 seconds. Homogenizing. Ice cream mix is homogenized, 2,500 to 3,000 pounds per square inch to decrease the milk fat globule size to form a better emulsion and contribute to a smoother, creamier ice cream. Age the mix. Ice cream mix is aged at 40 degrees Fahrenheit, 5 degrees Celsius, for at least 4 hours or overnight. Aging the mix cools it down before freezing, allows the milk fat to partially crystallize and gives the protein stabilizers time to hydrate. Flavoring. Liquid flavors and colors may be added to the mix before freezing. Only ingredients that are liquid can be added before the freezing, to make sure the mix flows properly through the freezing equipment.
Freezing. The process involves freezing the mix and incorporating air. Ice cream mix can be frozen in batch or continuous freezers, and the conditions used will depend on the type of freezer.
Packaging. Packaging and bundling the finished product. Automatic filling machines drop pre-printed pint or half-gallon sized cardboard cartons into holders. Harden. The ice cream is cooled as quickly as possible down to a holding temperature of less than -13 degrees Fahrenheit -25 degrees Celsius. The temperatures and times of cooling will depend on the type of storage freezer. Structure of ice cream. Ice crystals, air cells, fats globules and liquid syrup. Beating and aeration occur at the same time as freezing to form small air bubbles. Air makes up 30 to 50% of ice cream's final volume. During freezing, water become ice crystals.
Fats, proteins and emulsifier. Fats are important for the creaminess of the ice cream. Proteins from milk form a membrane around the fat droplets. Emulsifiers replace some milk protein on the surface of the fat droplets. When ice cream is made, some of the fat and droplets solidify. This causes fat needles to form, which help droplets cluster and creates air bubbles.
Stabilizers. Stabilizers are added in small amounts to ice cream. Stabilizers reduce the rate at which ice cream melts, add smoothness, and increase viscosity of the liquid phase of ice cream. Use of multiple stabilizers can produce synergetic effects. Flavors and colors. Vanilla flavoring is simply vanillin. Anthocyanins are used to give strawberry color to ice cream. Skatole is used as flavor enhancer. Skatole also found in feces but which has a floral odor at lower concentration.
The temperature in the ingredient is the most important to make a good ice cream through the step-by-step process and the chemical reaction behind the making of ice cream.